Good afternoon, everyone. I'm Damian Pumar. I'm a lead front-end engineer at Hugging. Uh, I'm Damian Pumar. I'm a lead front-end engineer at Hugging Face, and also I'm a technical coach. Today, we will explore how to apply clean architecture principles to front-end development. We will learn how to structure our application so that your business logic stay completely separate from any specific UI framework or presentation technology. But by the end of this talk, you will understand why this separation makes your code more maintainable, testable, and adaptable to future changes. So the base of this presentation is I would like to share with you this question: how do we move away from frameworks? For that reason, I would like to start the presentation just understand. Sorry, I just missed one slide. So I'm Damian Pumar, as I said before. To start this meetup, I would like to start talking about what is software architecture, right? Basically, the software architecture is the high-level grouping that define how an application's components are organized and interact each other. It covers the main module or layers, the design patterns we adopt, and the quality attributes we aim for, such as scalability, performance, and maintainability. So why clean architecture is the question for this case. I would like to share with you the next slide. Sorry, because I have a lot of screens here. One with YouTube, another one with the streamer. So why clean architecture? The clean architecture was popularized by Uncle Bob, Robert C. Martin, and the clean architecture offers several key advantages. Firstly, is the framework independent. You can swap your React application, for example, for Vue or Svelte without changing your business logic. That's really important point. Secondly, is the testability. Your business rules are isolated and can be unit tested without UI or any external dependency. Thirdly, you can the UI is independent as well. Your visual layer, your presentation layer, can evolve freely without forcing changes in your domain code. And the last point, very important to understand, is the clean architecture is really isolated, talking about external services. Basically, your integrations with APIs in outer layers keeping your core more pure as possible. Basically, the core of your application, your business logic, doesn't have any external dependency. This is the slide. Sorry again. So well, I moved here. Perfect. So the most important thing about clean architecture is the dependency rule. The dependency rule must point inward from outer layers toward the core. The business rule layer, the center, never depends on UI, frameworks, or third-party libraries. This ensures that your code remains free of side effects and easier to reason about. Well, this is the most important layer from my point of view, the entities layer or enterprise business rule. In the center, we have the entities. Those entities are objects or structures that embody the key concept of your domain. For example, in a shopping cart, the entity defines method to add or remove items and enforce validation rules. Entities know nothing about how data is presented or where it's stored, right? It's very important to understand that the entities never should have external dependencies. When I said, sorry, but one little detail. When we said external dependencies, we are talking about third-party libraries or any other dependency that we have in outer layers, right? For that reason, it's really important to understand the arrows here to maintain the dependency rule really strict. The second layer, going to the outers from entities to the framework and drivers, is the outer layer. So the use cases is or application business rule that this layer contains use cases which orchestrate entities to fulfill specific application workflows. For example, in this shopping cart application that I said as an example, imagine that you have the checkout use case. This use case checks the inventory or calculate totals or handle order submission, for example. These use cases remain independent of both UI components and data storage detail, for example. Well, the next layer is the interface adapter, that one, the color green, or the interface adapter serves as translator between the core and the outside world, for example. In the front-end context, this includes controller and that handle, for example, user inputs or presenter or view models is more or less the same, that format the data for the UI, for example, and gateways that adapt calls to external services. Well, and the last layer that I would like to explain is the frameworks and driver. This is the outermost layer. This contains frameworks and tools of your application. Your UI library, for example, your React dependency, your React library, or Vue.js if you want to use Vue, or Angular, or any HTTP client like Axios, or any Toaster notification library, or any other third-party library should be here in this outermost layer, in the framework and drivers. These layers depends only on the interface adapter and never directly on entities or use cases. Right? So, well, I would like to review if we have some comments. Not yet. Okay, fantastic. So we can move forward with another perspective for clean architecture diagram. So I don't know if you know, or if you know this diagram. Maybe you can write some comment on YouTube. But this diagram is the same diagram that we have here, but it's in another perspective. This is from side, and the other one is in another perspective. So I would like to share this diagram because as a cone, you can imagine that if you want to take this green layer, the interface adapter layer, if you have a cone, for example, and if you want to take the green layer with your fingers, right, you can put with you the use cases and the entity as well. But if you take just the entities, for example, you just take just your business logic, right, without any dependency here, right? That's the reason it's really important to understand these arrows, because those arrows mark the dependency direction. Well, I explained all the clean architecture theory, but this is the real clean architecture diagram in the front-end side, right? I would like to introduce some concepts around of this diagram, and also we will do a live coding session that we can put in practice some concepts around here. Well, this diagram is separated in three different layers, but it's the same it's the same concept that we have in clean architecture, but this is a clean architecture as well. But the presentation is the union from framework and drivers and interface and adapter, right? The presentation layer is those layers working together in the same place. Why? Because the front-end application, the 90% of the front-end application just have presentation business logic, right? For that reason, in the UI, in this square, in this rectangle, the UI, probably you should use your TSX components, like a buttons or whatever. But in the view model, you can use your interface and drivers layer like a view model, just to translate the information from UI button, for example, to our use cases, right? In those use cases and entities represent the other two. Sorry, I just remove the presentation. Sorry about that. 1 second. Right. Let me go to the the domain is the union of application business rule and the enterprise business rule, those layers in the same place. And the infrastructure layer, here we have the external services and the connection to the world, like your HTTP connection, for example, should be here in this layer. Well, this layer is basically that one. Yeah, for that reason, I would like always to explain clean architecture with those three layers. The presentation, to separate all the UI thing, UI buttons or inputs. The view model just to translate the input to our use cases. The use case, like an orchestrator, to handle and return the information from your business logic, your entities, and the entities just to interact with the infrastructure and the use cases. But here we have some important thing, because the entities, as I said before, never should have any external dependency. So for this reason, we need to create the inversion of control from your entities or even your use cases to our external service concrete implementation. Yeah, but no worry if you don't understand 100%, because in the live coding session we can move deep dive into those details, right? As you can see here in this scenario, here we have the dependency injection container to resolve those dependencies, but this dependency injection container is really related to resolve this dependency, this arrow here. Okay, so if you are curious, you can access of this to this link, scouts.fyi/ts injected. Here you can find the dependency injection container that I wrote some years ago. It's open source, you can use, feel free, just to resolve these dependencies and inject your concrete external services into your entities or even to your use cases. Okay, perfect. Another important thing to handle correctly some events in clean architecture is use domain events. Basically, the domain event is the action after the another action finished. That basically we can create events in the entities or even in the domain layer and dispatch it dispatch it your event coming from your entities or even in the use cases to the UI or even into your view models. So basically, the idea is just to handle some presentation responsibilities, but dispatch it from your domain layer. Imagine that if you have, for example, in the shopping cart application, imagine that you have one scenario, one casuistic that you need to inform the user that the users, cannot check out this order or one order because the total is higher than X number, for example. You can dispatch this domain event from the domain layer and handle it from the presentation layer and show, for example, the notification toaster, for example. Well, this little detail here in the entities is really interesting because in the entities rectangle, we have services, the domain services. Those services are just an interface. It's like a contract. It's not an implementation. The implementation exists here in the infrastructure layer that it represented as frameworks and drivers layer in the clean architecture. The models are your entities, basically your shopping cart, for example, your cart entity or your user entity or any business logic object that should have, business validation, for example, or even save the internal state and also the IDs. And the event is the domain event, of course. Perfect. So, we can move forward with the live coding session because I would like to explain all this theory in the practical exercise. But before to move to the coding session, I would like to share with you this link, the scouts.fyi/clean architecture shopping. There you have a project, the same project that I will be sharing with you today. And in another bullet point, we have the documentation, scout.fyi/library. In this library, you have a lot of information. So how to implement clean architecture in the front-end side, and also there you have some npm packages that might help you to implement and handle really difficult scenarios in the front-end side when you want to implement clean architecture. Okay, so before to start, I would like to share with you the application, right? This application that we have here. After to do a little introduction of the application and what is this application and what is the purposes and something like that, I would like to share with you the code, the related code of one or two use cases in this application. And after that, I would like to get some question from you just to discuss some little details about clean architecture and also the implementation that I made some years ago. Okay. Well, let's start with the implementation, right? The application. So this application is a shopping cart application. We sell here cookies, right? Each cookie has an image, title, and also ingredients that we have here. In this case, cherry and marshmallow. The application has the use case to log in, right? We can log in with admin and admin at admin.com. And after the user is logged in, you can see here more kind of cookies, right? And as you can see here, in this case, you have some emojis related of each cookie, right? Those cookies represent the preferences from this user and this cookie, right? If the ingredient has a thumb up, is preferenced by this user, but if the cookie has this warning, is related to an allergy. Yeah, basically this admin has an allergy of cherry, for example, in this case. In the user page, let me add one cookie in the cart, right? When I click here, you can see here appears the new cookie that I added on the cart, right? But here we have the allergies and the preferences. As you can see here, the marshmallow is a preference, but the cherry is an allergy of this admin. And we have here the logout, for example, and we can log out. Okay, let me say log in again. Perfect. So I would like to explain what happened if the user just click on the cherry. We can see here the new notification that said this cookie is dangerous for your health, because if I am this user, I am allergic of cherry, right? So for some reason in this application, the user cannot buy this cherry cookie, right? But if I try to add the cookie that I have some preferences in those toppings, so I can add on the cart, and also I can check out the order. After the order was created, I received the new notification say that the new order created correctly by a total 250 euros, and the timestamp here is not relevant, but is the use case that we have here. And you can see here the order is changing the status based on some business logic as well. So I don't know if you have some questions related to this. Yeah, I see here, Albert. Yeah, Albert, if you want to say something, just you can write in the channel, or in the comments, and I can read it after some explanation. So, well, I would like to explain little by little what happened in this application, and I would like to show you the folder structure, because it's really important to create folder structure correctly about or applying clean architecture. Here we have the UI. The UI is the presentation layer, right? Here we have, for example, the cookie. Yeah, this is the cookie component. The cookie component is an article, has a class name. This is the style, the CSS style. This is the image, right? This image here, the title here. So let me know if you can read correctly my code. If you want to zoom in, let me know, please. Here we have the toppings component that lists the toppings from this cookie, but pay attention here, because this topping received the user as a prop, right? And if the user is admin, I don't know why. This is the business logic here in the component side is like a presentation business logic, right? Has this button with the price here, and also the handler of this button is the add to cart and pass the cookie here. Okay, but if you can see here, the cart.contains cookie. If this condition is true, we just print in the document, in the DOM, this in your cart here. Something like that, basically, right? But pay attention here because it's really, really interesting what happened here. Because when I click here, yeah, the cart size is incremented by 1, right? And this condition is true, right? And we can take a look the add to cart just to understand what happened under the hood in this use case to reactivate or create a re-rendering in this part of the component to show this span here. But well, as I said, this is the cookie component. Here, each component in this application has a view model related. The view model is the translator between my component and the business logic, right? Here we have the user storage, cart storage, because obviously we need to get some references here just to pass the user here and just to understand if the user is an admin or not, and just to know if the cookie is contained here in the cart, right? So, well, those hooks are services. Those services exist in the frameworks and driver layer. Those hooks are use basically third-party libraries to handle the state and their activity. As you can see here in this application, I'm using React. In this case, those storage use Substance under the hood, but it's the same. If you want to use Redux or even you want to use any use state, is the same. But the most important thing here in this case is the UI layer has a React dependency, obviously, because this is the React component, and here, because this view model is a hook, right? So the hook and the React component need React.js as a library, right? As a library installed in your application. But here you can see the use result. This use result is a dependency injection container coming from code scout slash dependency injection, right? But you can take a look in the library, in the documentation library that I shared before, but no worries, I can share with you after the meetup. So this use resolve can resolve on the fly this use case. This use case, if I move quickly to this architecture, the UI component, the cookie component exists here in the UI, and in the presentation layer, we have this use cookies view model, right? But the domain layer has the use case here, and this is the use case, and the add to cart get the product here, or the cookie in this case, and execute the use case, just translating the handle click from the button to communicate with our domain layer. This execute receive the user instance. This user is the user that the user is logged in here, right? Is this user. The product, the cookie, basically, here. And this is the notifier that you can see if I click, for example, in a cookie that I have some allergy, right? So based on the toppings in this case. But I would like to explore this has an allergy because this user is a class. It's not a function. It's not. It's just a class with some dependencies and also some responsibilities, like understand if has or not allergy in this case. But basically, it's very, very easy to understand this business logic, right? If my allergies is in the ingredients coming from the product, obviously I have an allergy, so I need to return with this error in this case. But in case if the user is not has not allergy of this or any of those topics, we add the product into the cart, and after that we use the storage to update the cart into the storage internally. When the application executes this line, the UI is reactivated with the new cart instance, showing the new product here, for example. Yeah. Or even if I am here in the checkout page and I click here, you can see the cookies that I'm adding on the cart many times, right? So, but you can see here the add to cart use case has an execute method. This is the unique method or the unique public method that this use case has, and needs to depend or have two dependencies. Firstly, the cart storage, because I need to update the storage every time when this method is executed, right? And the other dependency is the notifier, just to notify the user some messages. But if we take a look here, this notification service is a domain service and is just an interface. And this notification service exists here into the domain, in the domain folder. The use case get all those dependencies coming from domain, right? Here we have the application, domain, UI, infrastructure, and the data has some fake data to create these random cookies. Those cookies components. But the use case exists here in the application layer or application folder. But this application folder is the use cases that I share with you here. Is the same. I put the name application because it's more correct for me instead of use cases, but it's the same in this case. But we can continue with the add to cart. This add to cart depends only with domain references. Into the domain we have model, like a cart in this case. In some seconds we can take a look here. The services, for example, in this case, notification service, or even the cart storage service. The cart storage service has just cart references, update to cart, and empty cart, just to something like clean the car or something like that. And the event if in another use case, we can take a look here. But basically, this is more or less the idea. We have a use case with two dependencies. In this case, one dependency I used for show the error, and the other one is just for update the card. Let me remove this line just to show you something. What happens if let me refresh the browser. If I click here, yeah, I'm clicking this button, but the UI is not reactivity. The UI doesn't have reactivity now because I just remove the line that I said to the UI. Hey, the card has some changes. You need to refresh your UI, right? But take a look when I refresh the browser. Yeah, we don't have any change, right? But I would like to explain or to show the notification service implementation because it's really interesting, because I am calling, or I'm trying to show the notification from domain layer. That's really powerful and really interesting. Here I can show the error. When the user click this button, we can see the notification here. This notification coming from our domain is not coming from the UI component. That's not a React dependency. That use case is just TypeScript and some dependencies coming from domain layer, right? The important thing here is the dependency injection container, that this component is responsible to create this instance. Let me show you the dependency injection to understand what happened under the hood when we use the use resolve here. In this case, this is the dependency injection file that responsible to create and register the dependencies. In this case, I try to build this use case with the dependency. This with dependency show you what is the first dependency is a card storage service, and the second dependency is the well, I need to put the comma here, is the notification service. But if you remember, this use card storage is the same that we are using here. It's the same instance and it's the same hook, right? Also, this hook coming from infrastructure services layer, coming from this library, is in the same layer. But this use notifier is the infrastructure service too, but with some custom library. For example, in this case, we are using React Hot Toast, but as you know, this hook implements this interface. In this case, this interface is the same interface that we are using here in this case. And the dependency injection is responsible to create and inject this dependency instance with those dependencies resolved. Right? Let me modify this little well here, and also I'll put here, right? I put a debugger here in this use notification just to understand what happened if the user tried to add in the cart some cookies that the user has some allergy. When I click here, let me increase a little bit the code. Here we have the user And this user has two allergies, cocoa and cherry in this case. This is my email, this is the ID, this is my name, the permissions, and some preferences, for example. But if I use, for example, I try to use here this console because it's the same. Here I can call the function, like a cherry, for example, maybe has allergy of the cherry, or cocoa, yes, well. But if I put another thing, this user has not allergy of this string in this case, right? So well, but if we move into this has allergy, we are iterating of the ingredients of this cookie, that one, the cherry, and understanding if the user has or not. And obviously, the product is the cherry cake and the toppings is cherry. Obviously, we get this notification. But we can step into the user use notification, and you can see here we jumped from domain layer to our frameworks and driver layer, right? We jumped from one inner core layer into our outermost layer, the framework and drivers, and the layer that might exist all those third-party libraries. And in this case, I delegate the responsibility to show the toaster to another external library. In this case, we get this information, right? So we have some comments here. So if I want to update cookie inventory when I add to cart, should I create a new service or add additional functionality to add? Yeah, imagine that if you want to increase your inventory, this inventory increase is a new use case in your application. So you need to create a new use case called inventory updater cookie, I don't know, use case. And in this use case, you need to create the business logic related to increase this inventory. But yeah, the answer is yes, you need to create the new use case instead of add a new method. Yeah. The answer is you need to create a new service or new use case in this case. Okay. Well, I would like to show you the magic under these toppings, because I didn't show you what happened with those toppings. Yeah, and it's really, really important, and also it's really interesting how this business logic works. Pay attention here because it's really, really important. Here is the toppings component. This is the topping component responsible to show this, basically those kind of emojis, right? Here I just put the ingredient, and depends of those kind of Boolean values, I put one or another one. Basically, in this case, I am iterating each toppings and delegate to the user entity to decide if I has a preference of this topping or if I has an allergy of this topic. It's really powerful using this approach, because the business logic to understand those kind of functionality or business logic is into user entity, not in the UI. If you want to use the conventional React developer approach, you should create a function here to take this decision, right? But moving to more clean architecture and moving to a way of any framework, you should create components like that with the entity and the another entity, and delegate to some entities the business logic to take some decision, in this case with some conditional rendering, right? Take a look this function. When I refresh the browser, I am iterating with putting some cookies into the DOM, right? And each cookie sends me the ingredient, and the user is responsible to take this decision, right? But the business logic is really, really simple. These preferences include the ingredient and return a Boolean, and that's it. Yeah, it's really, really easy to understand. But I think you remember that one important point to implement clean architecture is the testability. Test this function is really easy, right? You need to create a new instance of the user and call this function and assert to equal true if the ingredient is here, or false is not here, and that's all. It's really, really easy, right? So we have some question. How do you cover this use case? User add product to cart, user change preference to. So how do you cover this use case? When you said you cover, what does that mean really? User added product, marshmallow to cart, and the user change preferences to marshmallow allergy. So I'm not sure that I understand correctly this question. If you try to recreate the question, clean architecture has a lot of overhead. Okay. Yeah. One important thing to understand the clean architecture depends to multiple factors, but I would like to talk about it in the next slide. But yeah, you're right, Ruslan. It's not easy to implement, and if you want to create a really simple application and proof of concept application, obviously I recommend just to put the logic into some hooks and create more clean components, and that's all. The clean architecture in the front-end side has some concept around it to sometimes is not easy to implement it, and of course you need to write some extra code, but it's recommended for medium big application, or if you want to create some specific application, but I would like to talk about it in the next slide. Before to continue with the slide, I would like to show you the checkout, because here we have some really, really cool use case. I need 4 minutes. I will log out. I re-log in again because I need to empty my cart. But we can take a look on the fly what happened in this checkout button. Here is the button for checkout this order. Basically, this is my name, my email, this is my address here. So when I click on checkout, I would like to review with you what happened in this case. So as you can see here, we have the buy TSX component. That basically this component is, I think, is that component here, that one. So in the view model, we have the order product use case. We have the user storage, because I need to understand and I need to know what is the user login in my application. And also we have the use card storage. because I need the reference of my card because I need to do something here, right? This is the handle submit. Here we have some use state to set loading just to change this message, and that's all. But here we have the complex. Let me put the debugger, right? But well, I would like to say something, but it's more complicated. But we can continue. So here I put the debugger in the execute of this order product use case. This order product use case is responsible to handle my order and do the checkout, basically, right? When I click here, I am creating the new object, called order. This order has the user and the card. Why? Because into the order we have the card reference, the user ID reference, because obviously this card is referenced to the user. The status is new. The created is the new date, and the total is calculated by the card. Right here, I delegate the responsibility to create or to get the price cents or any value option that you want to use for handle this total, sometimes money or something like that. But yeah, here I create the order. Here I have my order, right? Here I have the card reference with the products inside. And also here, as you can see, here we have the order storage. This is the storage for save the orders. This is the storage. When I set storage, just in case, is the global state manager in this case. Here we have the payment service. This payment service simulate the checkout payment with Stripe or something like that. When I step into, I delegate the payment with the total. Obviously, it's very simple implementation, but it's just for testing purposes. I have here some implementation. This implementation is coming from infrastructure layer because we are using the same principle in each use case. All the dependencies coming from the domain and the implementation coming from the infrastructure layer. And here, if not paid, we notify we have not been able to process your payment and so on. But in this case, we can pay this order. And after that, I add the order into the storage. After that, I empty the card because obviously when the order was successfully paid and was successfully processed, we can clean the card. And just for clean the card, I instantiate a new card instance, and that's all, because I assume that the instance has 0 products into the card, right? After that, we dispatch this order, right? Maybe we don't have time to explain what happened with this domain event, but I can show you in the UI, but maybe we need more time to explain what happened internally. And after that, we have some set timeout. Those set timeout is just for simulate delivery scenarios to change the status on the fly, and that's all. Take a look. This notification coming from the event handler, and here you can see is changing the status internally from delivery to completed after 5 seconds or something like that. Yeah, 5 seconds each. So, but the important thing here is those methods just updating the order. Internally, we use the responsibility into order object, just changing the status here as well, right? So, well, this is more or less the use case, but I would like to show you this scenario. This we have not been able. As you can see here, the payment service, we have 2 kinds of payment service. Firstly, we have the payment from the domain. This is just an interface, but the secondly is coming from infrastructure. This is the implementation of the other one. And basically, that fake API simulate API connection is like a promise with timeout or something like that. Yeah, for 450 milliseconds, and return true if the amount is less than 500, and that's all. It's really, really easy. In this case, if I add 2 or 3 cookies into my cart, when I click on checkout, we receive here this message. We have not been able to process your payment. Basically, is this message here coming from here. But the important thing in this case is this notifier error coming from domain application, domain layer, instead to add this notification from components or from hooks. Yeah, those approach are more common in the conventional architecture in React projects. Just to answer the question from Ruslan before, I would like to show you when is it worth it? When is recommended to use clean architecture? If you want to build a white label application, for example, it's really, really interesting because you should have one business logic for multiple brands. For example, in this case, is very, very common. You are building a white label or multi-tenant application that reuse core logic across brands. It's very, very common scenario. Secondly, the business rules are shared across multiple platforms like web application, mobile, or desktop. Aman mentioned before that he's a React Native developer. So if you use React Native, for example, and you want to create application running in React for web technologies, and also you want to reuse your business logic, not the presentational, but your business, your core, your entity, your use cases, you want to use it in the same business logic in a mobile application, for example, you want to implement this clean architecture. Is really easy to maintain and grow in the future. If you have a front-end code base is really, really large and you expect to grow little by little, I highly recommend this kind of architecture. And another point, if you know that your application should have a lot of changes in the future, is highly recommended as well, because your business logic is in the one place and the UI or presentational component is in another place, and you can change libraries on the fly or even more easily. For example, one little thing before to move forward with the question session, if I do the same that before, sorry about that. If I want to change this this message, so you remember that this message, right? This cookie is dangerous. If I want to change this library, I need just to work here in just one line. My business logic is the same. For example, that one. When I change this line, I change that line as well. So I get this message with an alert in this case. But if in the future I need to change, for example, for React Native, one dependency for web application, use another dependencies, we just need to rewrite this service instead of change all my business logic, right? I think with this example, it's really easy to understand how powerful is this architecture. Well, questions. I have one from Alex. I mean, if a user add cookies with marshmallow to the cart and then change it in preferences, that, yeah, okay, now I understand your question. So it's very easy to handle it. If you think in the UI related how the user changed your preferences, in this UI, probably you should have a trigger, like a button or debounce function or something like that. After the user changed this preference, you can remove or even alert this user that some products into the cart should be removed because the previous product or the previous cookies has some allergy with the new one, right? So what is the step to tackle this scenario is create a new use case called allergy preferences update use case, for example. This use case should have has as a dependency the user storage, for example, and the user storage, and get the user in the execute argument from the execute method. And after change the preferences for this user, you need to inform to the user what happened. But the business logic coming from the user. You just need to create a new use case and handle this scenario, right? I would like to show you one little thing about the test. Just 2 seconds. This is the test, for example, to order products. Yeah. This is the test to test basically the payment fail when you create a cart with what the scenario is necessary to throw the error, right? So basically here in this case I just mocking the try pay and return false in this case, so the payment was not successfully. I call the execute, and after that I expect this message. It's very easy to do, and also should be in green, right? When the payment is successfully, I just put the true. And what is the expectation? The success to be called 0 time, or error to be called 0 times, and the order to be called once, and the empty cart once as well. So when I run this scenario, the test should be in green. Well, that's all. If you want to know a little bit more about this clean architecture, just ping me and contact me, and we can talk about it. So we can continue with the. Will you share the zip file? Yeah, the project is in the previous link, but I will review in GitHub, and I'll share with you in some minutes. Okay. What else? Show me for React Redux project clean architecture. Okay, so here we don't use the React Redux. We are using Substance now, but yeah, it's 100% compatible to use React Redux. In this case, we are using Substance, but yeah, I don't have it a project with React Redux now. So where do you want to start writing clean code? Do you start from writing use case or domain layer? So really good question. So it depends. If the business logic is really complex to manage, firstly, I would like to start writing the domain entity model, and also doing the test for this domain model. And little by little, moving to up to outer layer, like okay, I create the use case to consume this, entity, I write the orchestrator code and moving little by little to the UI. But sometimes if the business logic is really simple, like this scenario, this case that I shared with you before, I prefer start writing the code from the bottom, handle the click, and move it little by little to the inner layers. So I find the project, but I need some time to share with you the repo, because I need to find in on GitHub before. But yeah, that's all from my side. So I would like, and also I appreciate your feedback. If you want to contact me, or even to get in touch or send me feedback, just scan this QR. That's all. Thank you very much for this this meetup, and also we can keep in touch in LinkedIn or Telegram into the community. Well, the library that I use for dependency injection is mine, dependency injection library, but I can show you, because it's called TS Injecti. So I'll share with you here. This TS Injecti is an open source library to handle and manage dependencies in the front-end side, and also is 100% compatible with Node.js and something like that. Okay, thank you very much. See you. Bye-bye.